Welcome to Module A, Lecture 4. In this lecture, we will talk about the transport planning morphology. In Lecture 3, we discussed about various approaches for mitigating the externalities. Then we discussed why we need our transportation planning, urban transportation planning, or what is really the motivation for urban transportation planning. Then just started the discussion with transportation planning morphology and showed you the system engineering process for the transport planning morphology. So, let us go back to that last slide where we stopped in lecture 3. There is a socio-economic environment where that shows the current scenario, the current situation, and the problems what we are facing. And once we try to solve or try to improve something, then the very first thing is do the problem definition. Now, problem definition is actually everything to me. If we can do the problem definition properly, remaining steps are very easy. I mean, most problems occur because we are not able to define the problem correctly. So, we will come back to that. Then once we have done it, then we have to generate solutions, array of solutions. We will analyze each of those solutions, then evaluate them to pick up the best one, and then that gets implemented. And what I said in the last lecture, that this feedback arrow shows that it is a continuous process, because whatever you think is a problem today, accordingly you develop some strategy and implement it, improve it. After 1 year, after 2 year, after 3 year, or after certain time, again with increase in population, increase in travel demand, increase in the choice of mode and preference and everything, again the problem is going to come. So, it is always dynamic, right. You do something today, it will improve the situation immediately tomorrow, but then again after some time the problem will come back probably in some form or other, right, because of the natural growth. So, you have to continuously keep on updating and upgrading the system. So, that is what it shows, that it is a cyclic process. Coming to problem definition, the basic aim here is to define the interface between the system and the environment, and also to identify rule or criteria that may be used by the planner for identifying the optimal solution. So, what we mean by the problem definition, that is described in this slide. So, problem definition includes 6 major components. First, system objectives, that means we should clearly say or identify what are our objectives. We must understand what are our constraints, because constraints limit the boundary of meaningful solutions. Then we should clearly identify, if I want to do that, what kind of inputs I need, what will be my outputs, then how I will map the outputs with my objectives using the value function, and then how I am going to evaluate my alternative solution. So, what would be my decision criteria? Let us try to understand little bit more about the objectives. Now, when we say the objectives, it is important to probably understand 3 different terminologies. One is goal, another is objective, another is standard, right. Sometimes we use them interchangeably, right, but actually they mean different things. So, what we say, a goal is basically as a state what we try to get at the end of the plan, right. It is something which conveys you a meaning you can understand, but it does not give exact quantification measures or anything. For example, if you say social justice, okay, out of transport I am saying, okay, or say national unity, yes, we mean something, we understand what they mean, right. Is the current end of the goal what we are trying to get, right, what kind of state we are trying to get. But the objective is the lower order goal, which is at least conceptually is capable of being measured, right. So, goal we cannot measure, goal tells that what is the state finally we want, that is the kind of state we are going to achieve, right, we are trying to achieve. Objective is a lower order goal, something at least conceptually I can measure something. Our standard, the next one is a further lower order than an objective and represent a condition that is capable of both measurement and attainment, right. So, I am sure still probably it is not clear to you, and it would be good to take an transport example. Let us take that. Let us say in the context of transport, we can say the goal is to ensure that amenities of an urban area are available to all socioeconomic groups within the community. Okay? So, we are trying to say our goal is to ensure that amenities of an urban area are available to all economic or socioeconomic groups within the community. So, it can tell, yes, it tells you, but it does not tell you then what you will do. It tells you about the end state, that what you would like to achieve, but it does not tell you that what you need to do immediately, right, does not give any sense of quantification. So, the objective in this context with this corresponding goal could be to maximize and equalize the accessibility to urban activation by public transport from all residential areas. Okay. I want to say that if I have good public transport system from all residential area to all parts of the society, parts of the city, then any economic segment people, being it poor, being it rich, anybody can travel from one end to another end and can access all the amenities and facilities which are available within that urban area. Yes, you will certainly agree that this tells you something. Yes, I can at least conceptually I can measure that, okay, I know that what I have to do, right. So, I need to develop my public transport network covering each and every parts of the city, and then I can make sure that the amenities are available to all socioeconomic groups within the community. Okay. Standard is further a lower order goal than the objective. So, I can say the travel time not greater than 30 minutes, right, perfectly, you have a measurement now, right. So, you know that from any point to any point in the city, I should be able to travel by public transport system in not more than 30 minutes, fine. So, that is the goal, corresponding objective, corresponding standard. So, the problem of objective, defining the objective clearly for any kind of transport problems, what you are trying to solve is very, very important. We think that it is almost obvious, but believe me, that is the most challenging task. Next is, we must understand what are our constraints. I have seen in several occasions people came out with some solution of a problem which can never be implemented, because you know that probably there is a religious place which you cannot relocate, or you need to widen road which you cannot do because you cannot acquire the land, and so on and so forth, okay? Or came out with something which will require so much amount of money that the government does not have that much amount of money to spend. So, we want to avoid such kind of things. So, before even you think of moving further, once you have identified the objective, you must know what are your constraints. That tells you that what I cannot do, right. So, then I know that what is my domain, and within that feasible domain I have to find out a solution which can be implemented. I do not want to come out with a solution which cannot be implemented. If the government does not have that much fund, I must know a priori that what kind of fund is available, so that I come out with a solution which can match with the available fund. Because obviously, you know that you can solution is not just one solution. There are short term, long term, okay. There are capital intensive solution, there are management oriented solution or policy oriented solution. So, we must know. So, it is very, very important to understand the fiscal constraints on capital or operating expenditures, that okay, I can get one time money, but do not ask me money after that, or then after that I only have a limited money. Or you can say that okay, my operating expense is fine, but I do not have really so much capital investment, okay, capital to spend money initially. Similarly, we must know the legal constraints. There are many issues related to transport. What is how much legally is permitted, because otherwise you will do something, you will try to recommend something, do something, and tomorrow people will go to the court and get a stay order, finished, you cannot do anything then, because the case will continue, people have right to go for legal battle. So, you must understand the legal constraint. You must understand, can you get the land? In busy area of Bombay or Calcutta or some other city, you are trying to come out with a solution, you can tell many things, but you know that maybe a given context it is not possible to do land acquisition. So, it is meaningless to come out with a solution which will require land acquisition. Similarly, the political constraints, because all of us we live in a system where there could be political constraints, but we have to work within all those constraints. So, as far as possible, if we must try to identify our constraints and know them clearly, so that we know the limits, the extent of, we know what are the limits for the feasible solutions, right. So, I said here that the constraints of a system may be defined as those characters of the environment that limits the extent of feasible solution, and we must try to come out with a solution which is within this feasible domain. Third, we must be able to identify the inputs very clearly. I mean, not that we just go to the field and start collecting data. No, you clearly identify what are the requirements of your input. So, before going to the field, I must know that if I am going to do this work, what are my inputs. So, basic inputs for a transportation planning process basically are the demands for the movement of persons and goods between urban activity centers, because most cases it is within the urban area, and of course, their travel also do happen and happen a reasonable share may happen from outside the urban area to inside the urban area, right. So, or in the external to external, right, simply the road is passing through the urban area. So, what are the inputs, whatever may be the demand. So, demand is basically the primary input, and I would again like to remind you here that please keep in mind that demand is spatial and temporal. So, we need to understand the spatial pattern and the temporal pattern of the travel demand, because often the total demand during 24 hour may not be a problem. The problem is that demand on 1 or 2 hours, during 1 or 2 hours during the morning peak or in the evening peak. So, the temporal pattern we cannot miss. So, even the spatial pattern we cannot miss, because maybe people are travelling towards the IT hub, okay, or the CBD area where most of the government offices are located. Okay. So, estimation of future demand is absolutely and extremely important in the context of urban transportation planning. In fact, everything what we do in the urban transportation planning, you can say that is all demand forecasting, right, everything by mode, by route, okay, by land, or activity, okay, everywhere you can say it is all about demand forecasting. So, estimation of future travel demand is an important and crucial task, but it is often challenging also to estimate that. Then we must know a priori what will be my outputs from the work, what output I am going to get from all this work. Obviously, there are some major output or direct output and some are indirect output. We are interested in both, but more interested in the direct output. So, most cases the direct output in a transportation context is what? It is the travel time. Travel time between various parts of an urban area from one place to another place, how much is the travel time, and the travel time is a function of demand. Because when there is no traffic, early in the morning you are traveling, you may be covering that distance in 20 minutes, whereas in the peak time that may take 40 minutes or even 1 hour. Why? Because the more traffic is there. So, obviously, the travel time is also a function of the demand and the type of road, right, or what is the road capacity. There are other direct input, maybe the cost of travel, the accident, if you can predict that, and there are other secondary outputs, that is the impact of the transportation system had on spatial distribution of urban activities. Because as we said that land use and transport are interrelated. So, whatever is the transport system, if two places connectivity is good and you can reach faster and less congestion or so, obviously that will influence the development of that area. So, these are all various indirect inputs, even the emission and all other things. The next part is the value function. Value function is that when you see the transport outputs, the outputs may be multiple outputs and they are not in same units, maybe they are measured and expressed in variety of units. So, value function what we are trying to do, different units, can we convert them to one unit using certain multiplier. So, that is called the value function. So, use certain multipliers to bring different outputs to a common unit, and common unit which unit? Units of the objective, because we want to map the output with the objective. So, what I said here, the output variables are measured and expressed in a variety of unit. The value function is instrumental in transferring magnitudes of output variable into the relevant system objective. If everything is in rupees, then rupee to rupee I can compare very well. If everything is in terms of minute to minute I can compare. I cannot compare minute to rupee to distance, right. So, value function helps us to bring all the outputs to a common unit, so that you can map with the relevant system objective. So, value function is a procedure for mapping the magnitude of an output variable into the units of value in which the objective is measured. Let us give an example to further understand it. This is an example. You can say that accidents sometimes result to fatality, right. People may die because of that road accident. Sometimes it may cause severe injury, that people do not die, but the injury is really severe. Maybe you will lose some part of the hand, a leg or some permanent damage that happen, but okay, one may not die on road or one may not die actually. That is another type of thing. The other could be that nobody gets injured, nobody is killed, but only the property gets damaged. The vehicle go and destroy a roadside building, right. So, naturally if I want to compare one road to another road, now two roads, the number of fatal accident, the number of injury, severe injury, the number of property damage accident, all will be different. So, how do I compare? So, if I can compare, bring all these different types of accident to a common unit, right, using some kinds of weightage, appropriate weightage, then I can compare these two roads in terms of that total number. So, here you can say 34,000 into A1 plus 1800 into A2 plus 310 into A3. So, we are saying that if property damage is 310, then we are considering a major injury as 1800 and a fatal accident as 34,000. I mean, these are all different weightages. Do not think that that's the way we are considering the value of life, right. But for for planning purpose and for understanding quantifying the benefits due to improvement, you need to quantify such kind of things, right. So, now two roads having all different values of three types of impact or three types of accidents, I can say I can compare them very well using the value function. Now, the decision criteria, it tells you yes, you have alternative solutions. Now, you want to pick up the best one. So, I am saying, or rather that is what it should be, right. So, in the problem definition stage, we are deciding the decision criteria, not that we will start doing something and once the solution comes, then I will think how I am going to evaluate. You cannot do that. You have to decide the criteria a priori. It is like if you are doing a tendering, after getting the bids, you cannot decide that how you are going to evaluate, then you have to decide that well in advance. So, same way in the problem definition stage itself, we have to say clearly and decide what would be our criterion for evaluation. So, what we say the decision criterion, a rule that drives the system planner for identifying the optimal system. You have got many alternative solutions which are available, what you are going to take, right, which one you are going to select. So, example, you can say that okay, select the alternative with the maximum difference between the net present value of benefit and cost. You know that once you do something, there is capital investment, there are operational and maintenance costs, and all these happen over time. The traffic benefit also, you develop a road, the traffic maybe for 15 years or 20 years, the traffic which are all going to use the road gets benefited. So, they come in different times. So, you actually bring the all discounted benefit and all discounted cost, and then you compare and you say whatever will give me maximum difference, that means my gain is maximum there, right. So, in general, of course, we will discuss this thing in details if possible, but the net present value. So, you decide that the net present value, or you can say what will be my benefit and what will be my cost, and I will select the one where the benefit cost ratio is maximum. That means, if I have got 3 solutions, I will calculate in each case the B by C ratio, benefit to cost ratio, and I will select the one which is having the highest value, or net present value, that is the net present benefit, right. If it is positive, and most cases it will be positive only. So, otherwise we do not take that action. If the benefit is not higher than the cost, then we will not take that action. So, most cases it will be the positive value, that is benefit, net benefit. So, we want to select where the net benefit is maximum, we want to select it. Now, remember that whatever we said in the problem definition, 6 components we discussed, actually formal definition cannot be established for identifying the scope of problem definition. Actually, anything you say is included as a part of the problem definition. So, whatever we tried to discuss here and tried to indicate, you can consider them as a kind of concept which we tried to introduce and which we consider them as useful aid for the structuring of the problem. Now, adequacy of problem definition depends on the ability of the planner. So, these are the interrelation of the 6 components. You can see that you have defined objectives, you have identified the constraints, you have identified the inputs. The inputs are then fed to the system and then you are getting the output, okay. And now you are checking with the constraints and then only taking the probably the meaningful outputs, and then through value function you are actually mapping it on the objective and you have a decision criteria already there. So, based on that you are trying to select something. So, all these are very clearly defined. The next steps are simple. You simply generate an array of solution. So, what is an array of solution? It satisfies the previously established objective to a greater or lesser extent, and importantly do not violate any constraints. So, if it violates a constraint, then it is not a solution, right. So, we are trying to generate solutions which to a greater or lesser extent try to satisfy the system objective and which do not value the constraints. Then next you analyze the solution. So, here the aim is to predict the probable operating state of each of the alternative systems generated, given expectation about the state of the environment. Okay. That, and then in a system context we say the planner must predict the magnitude of the output variables given the input magnitudes and the system properties. So, we know what it is going to give, we analyze the solution completely. Once that is done, then we need to evaluate the alternative solutions, and what is our aim here? We want to actually identify the alternative that satisfies the objective to the greatest extent, right. And criterion we have already decided earlier. So, the data required are the output variable magnitudes predicted in the system analysis step and the value function and decision criteria identified in the problem definition step. So, now that is what we evaluate and we choice, that means we recommend the value. Then the recommended strategy is implemented for the benefit of the society to address the concern, to address the problems, and you remember the feedback arrow, it will go back to the system socioeconomic environment, right. So, just remember that we are coming problem definition, then solution generation, solution analysis, evaluation of choice, identifying the recommended strategy, then implementing it, and the arrow going back to the socioeconomic environment, because over time again you will find you will require to carry out similar works. Okay. So, that is what it is. Then to summarize, I would say we discussed about the transport planning morphology. I tried to tell you the importance of problem definition in the context of planning morphology. That is the most important component which require you to identify the objectives clearly, knowing the constraints clearly, identifying the inputs, identifying the outputs, identifying the value function to map the outputs to the unit of the objectives, and also to identify the decision criteria. And as I said, these are not that only these are the things, anything else is required also to be done in the problem definition stage. So, that is your preparation in a way, right. The remaining, following that you now generate your solution, analyze the solution, evaluate them, take the optimal one which maximize satisfy the objective to the maximum possible extent as per the evaluation criteria and implement it, right. So, that is what it is. So, that gives you then overview of the transport planning morphology. Thank you so much.